Welcome to this comprehensive guide on networking fundamentals, where we'll explore the essential components of digital communication, clients, servers, and the critical concept of authority in detail. This foundational knowledge is vital for anyone looking to understand how modern digital systems operate and interact. Networking fundamentals involve understanding the intricate mechanisms by which various digital devices communicate, share information, and efficiently utilize resources across a vast and interconnected digital landscape. This includes everything from your personal computer accessing a website to complex data centers exchanging massive amounts of information. Key concepts such as clients, servers, and the principle of authority are fundamental pillars that dictate precisely how data is managed, how control is exercised, and how interactions unfold within any network system, ensuring order and functionality. The client-server model stands as a foundational architectural paradigm in networking, where clients, typically end-user devices, initiate requests for services or resources from more powerful and specialized servers. This interaction forms the backbone of most internet services we use daily. Clients encompass a wide array of devices, including workstations, personal computers, laptops, smartphones, and other internet-enabled gadgets. These are the devices individuals use to interact directly with the network, browse the web, send emails, or access applications. Servers, on the other hand, are specialized, high-performance devices or programs designed to manage and provide resources, process client requests, and respond with the necessary data or services. They act as central hubs, serving multiple clients simultaneously. This client-server model offers significant advantages, including the centralization of data storage, which simplifies management and backup. It also significantly enhances security by allowing controlled access to resources and improves overall operational efficiency by optimizing resource allocation and processing. Client responsibilities are primarily focused on the user interface and interaction. This includes interacting with users, displaying information received from servers, and crucially, sending well-formed requests to the server for data or services. Conversely, server responsibilities are extensive and critical. They involve processing incoming client requests, managing vast amounts of data, ensuring the security and integrity of that data, and providing a wide array of services, from hosting websites to running complex applications. Servers are designed to host critical resources, applications, and services that are accessed by numerous clients simultaneously. This central hosting allows for efficient resource sharing and consistent access for all connected users. The client-server architecture relies heavily on a suite of standardized communication protocols, such as HTTP for web browsing, FTP for file transfers, or TCP/IP for fundamental internet communication, to ensure seamless and orderly network communication between devices. In this model, clients initiate communication by sending requests to the server. The server then processes these requests, performs the necessary operations, and subsequently responds with the requested data or service, effectively managing the entire communication flow and ensuring reliable data exchange. Servers are specifically engineered and optimized to handle multiple client requests concurrently, often numbering in the thousands or even millions. This capability is vital for maintaining high performance, ensuring continuous availability, and providing a responsive experience for all users. Now, let's delve into the crucial concept of authority in networking, which refers to the designated control and decision-making power assigned to specific entities or components within a network system. Understanding authority is key to designing robust and secure networks. This concept of authority is especially crucial in the realm of game development, where it plays a pivotal role in ensuring fair gameplay, preventing unauthorized modifications or cheating, and maintaining the integrity of the game state across all players. In the context of game development, particularly with Unity's networking solutions, server authority means that the server has ultimate and undisputed control over all game objects that do not explicitly represent players. This ensures that critical game elements are managed centrally. The server, acting as the authoritative source, manages all core game logic, rigorously enforces game rules, and serves as the single source of truth for all important game data, including player progress, inventory, and high scores, thereby preventing discrepancies and cheating. To further enhance the integrity and security of your game, cloud code can be effectively utilized to write and execute server-side game logic securely. This allows for complex operations and rule enforcement to occur in a trusted environment, away from client manipulation. Local authority, often referred to as client authority, is a mechanism that grants a specific local client control over a particular networked game object. This is typically used for objects where immediate client responsiveness is paramount, such as a player's own character. This approach is particularly useful and often preferred for controlling player movement and other immediate player actions, as it allows each client to manage their own player game object directly, resulting in a more responsive and fluid user experience without noticeable lag. To enable local player authority in Unity, you simply need to tick the Local Player Authority checkbox within the Network Identity component attached to your player game object. This simple step delegates control of that specific object to the owning client. Now, let's transition from theoretical concepts to practical application and explore how to implement these fundamental networking principles within two powerful development environments: Visual Studio for general programming and Unity 3D for interactive game development. Visual Studio provides a robust environment for simulating basic client-server interactions and building network applications from the ground up. Concurrently, Unity 3D offers specialized tools and frameworks for creating rich, interactive, and synchronized multiplayer experiences. First, we will begin by setting up a basic client-server application using the C# programming language within Visual Studio. This initial step will lay the groundwork for understanding fundamental network communication patterns. This demonstration will clearly illustrate the fundamental request-response model, which is at the heart of most network communications. We will show a client sending a specific request to a server, and then the server processing that request and sending back a corresponding response, which the client will then display. Next, we will delve into implementing TCP/IP communication, a cornerstone of reliable network data transfer. This section will meticulously show how to establish a stable and reliable connection between a client and a server, enabling them to exchange data packets consistently and without loss. This process involves the careful setup and configuration of network sockets, which serve as endpoints for communication, and the utilization of network streams for efficiently sending and receiving data packets across the established connection, ensuring orderly data flow. Finally, we will simulate different network topologies, such as a two-tier architecture, where the client directly communicates with the server without any intermediate layers. This direct communication model is common in many applications and provides a clear understanding of basic network structures. Moving into the Unity 3D environment, we'll begin our practical demonstrations by creating a network player using Unity's netcode for game objects. This powerful framework simplifies the complexities of multiplayer game development. This initial setup allows for a basic network player to successfully join a server and interact in real time within the shared game environment. This real-time interaction is crucial for any multiplayer game, enabling players to see and react to each other's actions instantly. To enable networking for your player character, you must attach a network object component to your player game object. This component is essential for managing its network identity and ensuring its state is synchronized across all connected clients. Next, we will implement server authority to manage critical game logic and rigorously enforce game rules directly on the server. This server-side control is a primary defense against cheating and ensures a fair and consistent gameplay experience for everyone. To achieve server authority, we will utilize server RPCs or remote procedure calls. These allow a client to request the server to execute a specific piece of code, ensuring that important game actions are validated and processed by the trusted server. Then, we'll demonstrate the implementation of local authority, which grants clients direct control over their own player game objects. This is particularly beneficial for actions requiring immediate feedback, such as character movement, providing a highly responsive feel. To enable this, you need to ensure the Local Player Authority checkbox is enabled on the Network Identity component of your player. Additionally, attaching and configuring the Network Transform component is crucial for synchronizing movement efficiently. The network transform component is specifically designed to efficiently send movement information, including position, rotation, and scale, from the controlling client to the server, and subsequently to all other connected clients, ensuring smooth and synchronized player movement across the network. We'll also show you how to effectively spawn new objects on the server and ensure their state is accurately synchronized across all connected clients. This is vital for dynamic game worlds where objects appear and disappear, such as collectible items or projectiles. Network variables are an essential tool for synchronizing custom data types, such as player health, scores, or inventory items, ensuring absolute consistency across the entire network. They automatically handle the replication of data changes to all relevant clients. Finally, we'll touch upon the concept of distributed authority, which involves sharing network responsibility and control across multiple clients. This advanced technique can be beneficial in certain scenarios to optimize network performance and reduce server load. This approach, when implemented correctly, can significantly improve game performance by distributing processing load and simplify complex network architectures by decentralizing certain aspects of control, leading to a more scalable and efficient system. To implement distributed authority effectively, you can use network object ownership to precisely control which client has the designated authority over specific objects within a distributed system. This allows for fine-grained control over network responsibilities. Understanding these fundamental concepts of clients, servers, and authority is absolutely crucial for building robust, scalable, and secure networked applications and engaging multiplayer games that can withstand the demands of real-world usage. By mastering the intricacies of clients, servers, and the various forms of authority, you will be well-equipped to create truly engaging, reliable, and high-performance multiplayer experiences that delight users and stand a test of time. We sincerely hope this comprehensive guide has provided you with a clear, step-by-step understanding of networking fundamentals, complete with practical demonstrations in both Visual Studio and Unity 3D. Thank you for watching and learning with us.